Hello friends, in this video we'll discuss one problem of projectile motion. This problem is from your module. What they have given, we'll see that first. They have fired one projectile P with the initial velocity of 200 meter per second and angle of elevation of 60 degree, and after some time they fired one more projectile M. Actually it is a missile to destroy this projectile P, and the speed and the angle of elevation of this M is 2000 meter per second and a 45-degree angle. Now what they have asked us to find out the horizontal distance, height and time with respect to P firing at which the destruction takes place. Now what things we need to find out? First, let us see what is happening here. We have fired a P projectile, it may be anything. After that we have fired one missile M after some time, and let us say they are this missile is destroying this P projectile at this point. Okay, their projectile will intersect at a certain point, and let's say that point is this. uh, Now what they have asked us to find out the height of this point, okay, at which the destruction takes place, height of the point at which destruction takes place, then the horizontal distance from this initial firing point, okay, this horizontal distance, and the time required, okay, or time at which the destruction takes place from the firing point of P. That means the time gap between firing of P to the destruction takes place. This we have to find out. Now if you see that the projectile P and M, they are going to intersect at a certain point. If you see the projectile P having a less velocity, more angle of elevation, it will travel, let's say, like this, and projectile M with more velocity, far more velocity, it will travel like this. Okay, as of now we don't know how they are going to where they are going to intersect. Let's say they are intersecting here, okay, and this is the destruction point, and we have to find out this height and this horizontal distance. Now you know that the relation between the x and y, if you consider the vertical height of this point as y and horizontal distance from the initial point as x, then you know that we all in previous videos this is been discussed that the relation between y and x can be given by this formula, that is y is equal to x tan theta minus gx square upon 2u square cos square theta. Now this u is initial absolute velocity, okay, these 200 and 2000, they are absolute velocity. Okay, this muzzle velocity means the initial velocity. Okay, now this formula we know, and one thing you need to understand here, that this x and y for both the projectile will be same. See here, as they are intersecting at this point, okay, this x is same for this P and M, and also this height is same for this P and M. That means this y and x at this point will be same for both the projectiles. This you need to understand. Now from this, as we know theta and initial velocities, we can form two equations, okay, having common x and y. So for point or for projectile P, we can write or formulate the equation as y is equal to x tan of 60 minus 9.81 x square upon 2 into 200 square cos square 60. If you simplify this equation, you will get this equation. Let's consider this as equation number 1. Now for M missile, the same formula we can apply. Y is equal to x tan 45 minus 9.81 x square upon 2 into 2000 square cos square 45. 45 is the angle of elevation and 2000 is the initial velocity. If you simplify this, you will get this equation. Let's say this equation number 2. Now if you put y is equal to this in this equation, you will get x as 1499.85 meter, uh, almost 1500, and y as 1494.33. So two things we got, that is height of this point. Okay, let's say it is having x and y coordinates. So height, that is y, and horizontal distance, the second one, that is x. These two things we have got. Now time with respect to p at which the destruction takes place. Now when we fire t from that point to the destruction point, how much time it covers? It is it will be very simple. Now let's consider projectile of p projectile, and we can use this formula, s is equal to ut plus half at square, where s is the vertical distance. Okay, vertical distance from the initial point to this point of destruction. U is the velocity in vertical direction, initial velocity in vertical direction of the projectile. Okay, remember, don't get confused between this u and this u. This is the absolute one velocity, and this is the vertical velocity. These all things are vertical here. If you see, acceleration due to gravity is vertical in nature. U also we are considering it as a vertical, s also vertical, and time required to travel that vertical distance we are going to find out. Now s will be for point p and for point m. For both the projectile it will be the same. The s, that is the vertical distance from initial to this point, that is y, that we have calculated here. So s is 1494.33 is equal to u is 200 sine 60, that is vertical velocity, into t, plus half into minus 9.81, acceleration due to gravity is negative, into t square. Now if you calculate the value of t, you will get 2 time, that is 20.31 and 14.995. Now why we got this two times, and what is the meaning of that? Let us understand it. What is happening? What we have done here, we have took uh, we took s as 1409 94.33. Okay, so the projectile p, if you see, it is traveling like this. Okay, it is covering a path like this, and if you see at 14.995 second, okay, it is attaining that height that we took, 1494.33, and after some time, that is after 20.31 second, it is at the same height that we took. Okay, that means they are at the same horizontal level. So this point, okay, of is reached after 14.995 second. This point is reached after 20.31 seconds. So among these two, which point to take, or where the destruction takes place, how that can be calculated? See here, we know the coordinate of the point where the destruction takes place. Okay, the vertical coordinate we have as this y, and this is the horizontal coordinate, almost 1500. So whichever point it may be, the horizontal distance, okay, it should be 1500, almost 1500. Okay, that is 1499.85. So how to find that horizontal distance? Okay, uh, what we got, will take individual time, and we'll try to find out that horizontal distances. As we know that there is no change of velocity in horizontal direction. Okay, we can directly use this distance is equal to speed into time formula. So for let's say for this point, that means for this time will have horizontal speed, okay, it's 200 cos 60 into sorry, we are taking for this point first. Okay, let's find out the horizontal distance for this point. So horizontal velocity into time. So time is 20.31 and horizontal velocity is this. You will get x, that is horizontal distance traveled, as 2031 meter. And if you do for this point, that is for 14.995 seconds, horizontal speed into time, you will get 1499.5, which is almost equal to this. Okay, that means the destruction takes place at this point and not at this point. Okay, so our answer will be this one, 14.995 seconds, which is almost 15 seconds. So hope you have understood this. Thank you.